Let us continue with exercise 8D trigonometry. Question number 3.3. We have to prove the following identities. Here we have cosec theta square root 1 minus cos square theta. We have to see that it is equal to 1. So here cosec theta, leave it like that. Then inside the square root, if you see, we have 1 minus cos square theta. If you look at the identity, this one will be equal to sine square theta. Right hand side we want only 1. Then cosec we know from the relation it is equal to 1 by sine theta. Here you have sine square, so if we take it out it will become only sine theta. So sine theta up, sine theta down, you get cancel equal to 1, which is equal to right hand side. So that is how we prove left hand side equal right hand side. Then next for 1 we have 2 cos square theta by plus 2 by 1 plus cot square theta. We have to show that it is equal to 1. So we take the left hand side to be cos square theta plus 2 1 plus cot theta. So this one let it be like that because our aim is to get 2. Then 2 let it remain 2. 1 plus cot square theta, if we check from the identity, it will be equal to cosec square theta. So here we have 2 2. We can take common 2. So cos square remain cos square. 1 by cosec square theta from relation. 1 by cosec equal to sine square theta. We take common 2. So here we are left with cos square plus sine square because 2 already taken common. If you look here, cos square theta plus sine square theta, from identity it is equal to 1. So 1 equal to will be equal to 2, which is equal to right hand side. Then next we will see number 4.2. We have 1 plus tan square theta by 1 plus sec theta equal sec theta. We want only sec theta. So tan square theta we can replace value from identity. We know that it is equal to sec square theta minus 1. Then here 1, no problem, we can write 1 square. Because here you have 1 plus sec theta. So this one now we can apply the formula a square minus b square. So we can write a minus b, a plus b. Our a is sec theta. Then minus b is 1, sec theta plus 1. Then this is with plus sign, this is with plus sign, we can cancel. So 1 minus 1 will become 0. Then we are left only with sec theta, which is equal to right hand side. Then next one we have 1 by 1 plus tan square theta plus 1 plus cot square theta. In the right hand side we want only 1. So take the left hand side from identity. 1 plus tan square theta we know equal to sec square theta. 1 plus cot square theta equal cosec square theta. So 1 by sec it is equal to cos. 1 by cos we know it is equal to sine. So from identity cos square theta plus sine square theta we know it is equal to 1, which is equal to right hand side. Then next we have this one we have cos theta in the numerator. This side we want it in the denominator. Here we have 1 minus sine in the denominator. Here we have 1 plus sine. So what to do in this case? Since here we have minus, there we have plus. We rationalize the denominator. Cos, let it be like that. Here we have 1 minus sine. We can rationalize with 1, but opposite in sign. We have minus. We multiply with plus. Sin theta same. The one which we rationalize here, we also have to take it up. So that if we cancel, we'll get back the original. Then numerator, we cannot do anything. Leave it like that. The denominator. Here we have, like now, a minus b, a plus b. So we can apply the formula a square minus b square. Then numerator we cannot do anything, let it be like that. Then from identity 1 minus sine square theta it is equal to cos square theta. Here it is cos 1, here cos 2. So one of the cos will get cancel. Then we are left with 1 plus sine theta by cos theta, which is equal to right hand side. So similar way here we have 1 plus, there we want 1 minus. So what shall we do? The same way we will rationalize the denominator, numerator, leave it like that. Here we have 1 plus, we can multiply with 1 minus. Then the one which we put down, we also take it up, so that if we cancel, original will remain. Numerator cannot do anything, let it be like that. Here we can apply a plus b, a minus b, it become a square minus b square from formula. Then if you look from identity, because here 1 into 1, 1, 1 minus sine square, we know it is equal to cos square. So here we have 2 cos, here we have 1. So 1 will get cancelled. We are left with 1 minus sine by cos theta, which is equal to right hand side. Then same way, next one we have 1 by 1 plus sine theta. Then plus 1 by 1 minus sine theta. We have to produce 2 sec square theta. We have fraction both case, so we can find out the LCM. If we look at the denominator, 1 plus sine, 1 minus sines. So since the sign are different, we can take both as LCM. So if I divide this one and this one, we are left with 1 minus sine theta. So 1 into 1, 1 minus sine theta. Then plus this one, we get cancel this one, we are left with 1 plus sine. So this one multiply, we get those. Sine theta plus sine theta minus, we cancel. 1 plus 1, 2. Here a plus b, a minus b. It will be using identity a square minus b square. So 1 into 1, 1 minus sine square. From identity, 1 minus sine square is equal to cos square. 2, let it be like that. Then 1 by cos, we have sec. Then we have square, it becomes sec square theta, which is equal to right hand side. So let us continue to the next question. We have here cosec theta plus sin theta, cosec theta minus sin theta. We need to get cos square theta plus cos square theta. If we look cosec, cosec, sin, sin. 1 plus 1 minus. So we can apply identity a plus b, a minus b, a square minus b square. Our a is cosec theta, our b is sin theta. Then here we want cos and cot. So let's apply the identity. Cosec square theta, we know it is cot square theta plus 1. Then sin square theta, we know 1 minus cos square theta. So this one we cannot do anything like this. Here this minus into minus to plus, minus to minus become plus. 1 minus 1, 0. We are left with cot square theta plus cos square theta, which is equal to right hand side. Then next we have tan square theta minus sin square theta. We want tan square theta, sin square theta. When things get complicated, we better change everything to sin and cos. So in place of tan square theta with the definition, the relation, we know that tan equals sin by cos. Since we have square, we put square. Then now we get fraction. So let's take LCM 1 and cos square theta. Cos square theta will be, then sin, we can take common. So this side are left with 1. 1 divide cos, cos into 1, it will become cos square theta. From identity, 1 minus cos square theta equals sin square theta. So here we see sin by cos, it is equal to tan. We have square, we put square. 1 minus cos square, from identity we have sin square theta, which is equal to right hand side. Then here we have 1 plus tan square theta, from identity equal to sec square theta. Here 1, 1 minus plus sin. We can apply a minus b, a plus b. It will become a square minus b square. Then 1 minus sin square, we know cos square theta. The relation sec theta equal 1 by cos square. So cos square cancel. We are left with 1. Okay. So that is how left hand side equal to right hand side.